First, the objective of this lab to experimental verify the triangle construction or parallelogram law of vector addition by using force table. Number 2, to understand the basic concept of force vector. Number 3, to draw the force vector diagram. Number 4, to find and analyze the resultant force and direction from force vector diagram. Okay, number 2 is theory or introduction. A study of motion will involve the introduction of a variety of quantities that are used to describe the physical world. Examples of such quantities include distance, displacement, speed, velocity, acceleration, force, mass, momentum, energy, work, power. All these quantities can be divided into two categories: vector and scalar. A vector quantity is a quantity that is fully described by both magnitude and direction. On the other hand, a scalar quantity is a quantity that is fully described by its magnitude. The emphasis of this unit is to understand some fundamental about vector and to apply the fundamental in order to understand motion and force that occur in two dimensions. Continue. Vector quantities are often represented by scale vector diagram. Vector diagram depict a vector by use an arrow drawn to scale in a specific direction. Vector diagram were introduced and used in earlier unit to depict the force acting upon an object. Such diagrams are commonly called as free body diagram. An example of a scale vector diagram is shown in diagram below. The vector diagram depicts a displacement vector. Observe that there are several characteristics of this diagram that make it an appropriately drawn vector diagram. First, a scale is clearly listed. 2. A vector arrow with arrowhead is drawn in a specific direction. The vector arrow has a head and a tail. Last one is the magnitude and direction of the vector is clearly labeled. In this case, the diagram shows the magnitude is 20 meter and the direction is 30 degrees west of north. Number 3 is equipment or apparatus. First is force table. The function is a tool, demonstrable Newton's first law and how vector work. Number 2 is pulley. A wheel on an axle or shaft that designed to support movement and change of direction of a taut cable or belt, or transfer of power between the shaft and cable or belt. Number 3 is hanger, weight hanger. Used to handle the set of weight and is mounted with a string which is simulated as weightless. Number 4 is protector. Can be used to measure the angle. Number 5, the last one is string. Used to tie, bind or hang other objects. Number 4 is procedure. First step, as shown in figure 1 below, set up the apparatus and material. Number 2, Circle the direction force and direction force value and hanging the right weight for each angle given. Number 3, at the result table below, record the data. Number 4, on X and Y axis, calculate all the force acting. Number 5 is, and the last step is, with data given on table 2, repeat the experiment.
Result has two table. Table 1 simple mass, weight force, angle, and angle action. F1 19 for mass, 19 over 1000 1000 over 1000 multiplied 9.81 0.88. Angel 112.5. Reaction CW F2 19 over 1000 multiplied 9.81 as 0.88. and angel 215 CW F3 70 over 100 multiplied 9.81 has 0.69. Angel 0 CW and table 2 F1 80 over 1000 and multiply 9.81 as 0.78. Angel 247 CW F2 100 over 1000 multiply 9.81 as 0.981. and here 130 CW F3 19 over 1000 multiply 9.81 as 0.88. Angel 0 CW. Data analysis table 3 F1 F2 F8 Fy F1 Fx 0.88 sin 22.5 as negative 0.337 newtons. F2 Fx 0.88 cos 17 has negative 0.301 newton. Fy F1 0.88 cos 22.5 has 0.813 newton. F2 Fy 0.88 sin 17 has negative 0.827 newton. And F1 has negative 0.337 x plus 0.813 y. F2 negative 0.301 x minus 0.827. To find F3, negative bracket F1 plus F2 bracket F3 negative 0.337 minus 0.301 bracket x plus bracket 0.813 0.813, okay, minus 0.827 bracket y. This answer of this, okay, answer of this f3, okay, square root bracket 0.638 bracket 2 plus bracket minus 0.014 minus bracket 2 square root 2, and square root 0.40724. This answer is 0.638 Newton. To find the theta, as tan shift tan bracket y over x bracket shift tan must bracket 0.014 over 0.638 as 1.250 theta. Is table 3. Force direction, magnetic force on x-axis, magnetic force on y-axis, F1, F2, Fr, F3. Direction of F1 22.5, magnetic axis negative 0.337, y-axis 0.313, 0.813, F2 17 for direction, magnetic axis negative 0.310, y-axis negative 0.827, F3 direction 1.257, x-axis 0.683, x-axis negative 0.14, fx f0, fy negative 0.028. This is table 4. F1 fx, F2 fy, F2 fx 0.78 cos 1667, as the answer is negative 0.305 Newton. F2 0.98 since 14 as negative 0.630 Newton. Fy F1 0.78 since 1667 as negative 0.718 Newton. F2 Fy 0.98 cos 14 as 0.751 Newton. F1 0.305 x minus 0.718 y. F2 negative 0.630 x plus 0.751 y. To find F3 as negative bracket F2 plus F2 bracket negatives F1 refer from table x negative 0.305 minus 0.6 0.630, negative 0.630 x plus bracket negative 0.718 plus 0.751 y. This answer for minus negative 0.935 bracket x plus 0.033 y, and multiplies for x plus y dapat 0.935x minus 0.033y, and f3 0. Bracket 0. Square root bracket 0.935 bracket square root 2 plus bracket negative 0.033 bracket square root 2, and the answer is 0.8875 square root again, and this answer 0.935 to this to find the data equal shift tan bracket y over x bracket shift tan bracket 0.033 over 0.935 bracket, and the answer is 2.02. Table 4, force Fn and Newton, direction magnetic force on x axis, magnetic force on y axis, F1, F2, F3. F1 direction 67, x axis negative 0.05 Newton, y axis negative 0.71x Newton, F2 direction 40, x axis negative 0.630 Newton, and y 0.75 Newton, F3 for direction 2.02, x axis 0.935 Newton, y negative 0.033, fx 0, fy 0. This is free body diagram. F1 has 18 gram, convert to kg 0.08 kg 0.08 plus 0.08 multiplies 9.81 as 0.78 Newton, and F1x as 0.78 cos 16.7 as 0.305 Newton, F1y 0.78 sin 67 has 0.718 Newton. For F2 100 gram, convert to kg at 0.1 multiply 9.81 Newton as 0.98 Newton. F2x 0.98 sin 30 F2 F2x 0.8 0.98 sin 14 negative 0.630 Newton. F2y 0.9 8 cos 40. Free body diagram for table 3. 316 minus 137 minus 137 has 80, 86 and 80 over 2 the square. The answer is 43. FR square root 2 0.8 0.78 0.78 square root 2 plus 0.98 square root 2 minus 2 bracket 0.78 bracket 0.98 bracket cos 43 FR square root 2 equal 0.451 double R equal 0.451 square root FR 0.37 and the answer is 0.67 Newton. This formula A over sin A equal B over sin B. 0.78 over sin alpha equal 0.67 over sin 43. Sin alpha equal 0.78 x sin 43 over 0.64. Sin alpha equal 0.532 over 0.67. Sin alpha plus sin alpha equal 0.794 alpha sin convert and sin shift bracket 0.794 bracket equal the answer is 52.56. Theta minus alpha equal 70. If theta plus 52.56 equal 17. Theta equal 17 minus 52.56. The answer is 17.44 and FR equal 0.67 Newton. FRX 0.67 cos 17.44 and the answer is 0.639 Newton. FRY 0.201 and Newton. Discussion. As mentioned above, a vector quantity has both magnitude and direction. A vector is usually represented by an arrow, where the direction of the arrow represents the direction of the vector, and the length of the arrow represents the magnitude of the vector. In the three dimension, a vector directed out of the page along the positive z-axis is represented by a circle with a dot inside it, and a vector directed into the page or along the negative z-axis is represented by a circle with an x inside it. Conclusion: when we place a mass on a fourth order equation to the magnitude of the resultant, the ring turns to equilibrium. That means the force of the fourth mass is equal to the resultant force of the first three mass. The experiment proved that force has direction and a resultant force consistent resolve vector force.